This is a short lesson just covering some of the basics of integration. If I'm given that the integral from a to b of f of x dx is 5, and then I'm given that the integral from c to d of that same function f of x dx is 6, these are just some illustrations of some properties that we have. First of all, the integral from, let's kind of erase the right side of limits of that one and make an integral from b to c. So fix that. But let's say that I've got the integral from a to c of f of x dx. That would have to be the same as the integral from a to b of f of x dx plus the integral from b to c of f of x dx. And we note from above that this right here is equal to 5, this right here is equal to 6, so 5 plus 6 has to be 11. And that should make sense that if I have a curve, and this is the A, this is B, and this is C, that if an integral represents the area between the curve and the x-axis, that the area of one plus the area of the other should be equal to the area of the whole thing. Some other properties. The integral from b to a of f of x dx. So I switch the limits from up above. If I look at this right here, I have the integral from a to b is 5. So if I do the integral from b to a, we kind of hinted to that last week, that is equal to -5, which brings about our property that the integral from a to b of f of x dx is equal to the opposite of the integral from b to a of f of x dx. Number 3, let's say that I have the integral from a to b of 2 times the function f of x dx minus the integral from b to c of f of x over 5 minus 2 dx. So this we want to try to split up into things that we know or things that we don't know. Actually, I wouldn't be able to do the minus 2 at all, but so let me cross that out. Let's just do this integral from f of x dx, or f of x over 5 dx. What I'm actually doing is I'm actually doing a constant multiplier rule. I'm going to write that down, the constant multiplier, which says that this is the same as 2 times the integral from a to b of f of x dx minus 1/5 times the integral from b to c of f of x dx. That means that if I just do some substitutions, I know that this was equal to 5 and this was equal to 6. So this becomes 2 times 5 minus 1/5 times 6, or 10 minus 6/5, or 44 over 5. And finally, if I talk about the integral from a to a of f of x dx, that is just equal to 0. And that should be evident because if this is a sliver of a curve, and I'm just talking about a, and this, we're talking about the area of that rectangle. It has an infinitely small width, or a 0 width, so that'd be an area of 0. Told you this was short. We're just going to do one more little set of problems that you should see on your assignment. So this is another set where I'm given that the integral from 1 to 3 of x squared dx is equal to 26/3. I actually gave more when I did this with AB. I'm going to give you less and see if we can kind of get some of these problems. So we're going to do the integral from 3 to 1 of -3x squared plus 1 dx. And we're just going to use this. So for some of you out there, Carl, you cannot use any other integration properties that you may know at this point. We don't formally know those yet. What I am going to do is I'm going to factor a negative out of this polynomial and switch the limits to become from 1 to 3. So we get 3x squared minus 1 dx. Then I'm going to split this, make this 3 times the integral from 1 to 3 of x squared dx minus the integral from 1 to 3 of 1 dx. Breaking this up because I can do a substitution on this part. I'm actually given that that is 26 thirds, so this is 3 times 26 thirds minus this right here is just the area of a rectangle from 1 to 3 with a height of 1. So that should just be, well, 3 minus 1 is 2. That area would just be 2 units. So this is 2. I get 26 minus 2, or 24. Let's do another example using the same things we had up above. We're going to do the integral from 1 to 2 of x squared minus x plus dx plus the integral from 2 to 3 of x squared minus x dx. What you should see with this, we're given the integral up here from 1 to 3. Well, if these match, I'm going from 1 to 2 and then from 2 to 3. So this is the same as the integral from 1 to 3 of x squared minus x dx. And if I split that up into multiple integrals, I have the integral from 1 to 3 of x squared dx minus the integral from 1 to 3 of x dx. This first one is again 26 thirds, and this second one is the area of a trapezoid. That if I have a trapezoid where x equals 1 to x equals 3, this would be the ordered pair 1, 1. This would be the ordered pair 3, 3. And if I split this up and kind of evaluate the area of this trapezoid, it'd be 1/2. The height is 2, and the base 1 plus base 2 would be 4. So this area is just 4. So 26 thirds minus 4 is 14 thirds. And lastly, let's say that I have the integral from 1 to 3 of negative x squared plus 4x minus 3 dx. So I'm going to split this up into multiple pieces. Negative integral from 1 to 3 of x squared dx plus 4 times the integral from 1 to 3 of x dx minus 3 times the integral from 1 to 3 of 1 dx. This is about as easy as you can do it without knowing integration rules. Again, we have the first one is just 26 thirds. The second one is plus 4 times this integral, and we actually did that same one right here. If I look and just compare that with what we just did right there, we know that that integral is 4. So this is just 4 times 4 minus 3 times, we've actually already done that one before too. Remember, that was that rectangle from 1 to 3 with a height of 1, so that is an area of 2. 3 times 2. So you have negative 26 thirds plus 16 minus 6, or negative 26 thirds plus 30 thirds, or 4 over 3.